Dear students and the participants of the course on railway engineering, today we are going to discuss about the turnouts and points and crossings. In the last lecture, we talked about the realignment of the curves. We discussed about the various reasons why this realignment is required. We also talked about the permissible limits, and then the way it is being done, the procedure named as a string line operation was discussed. We discussed about the realignment with respect to the double and the multiple tracks also. So, what are the points which needs to be taken into consideration? And towards the end, we talked about the rail cutting and the provision of the jack rails. In today's discussion, we will be taking up two things, turnouts and points and crossings. We will be starting with the turnouts, wherein we will discuss about the various components and terminologies, and then we will just touch upon the points and crossings, and we will continue with this discussion in the next lecture. Now, what is a turnout? Now, if you see on the right hand side, a photograph is being shown. There is a straight track going here and another track is coming out of that straight track. Say we can say maybe this is a main line and another one is a branch line. So, when we provide this type of an arrangement, this turning which is being provided, which just diverges from the main track, is a turnout. So, the turnout is nothing but it is a simple arrangement of points and crossings which enable the movement of a train from one track or route to another track. Now, when we say there are points and crossings, this is the location where the two tracks are crossing, whereas the points are provided in this area on the basis of which it will be defined whether the train is going to be moving straight or it is going to take a turn and will come towards this right hand side turnout. The combination of the lead rails with the curved rails and fastenings, they help in diverting the rolling stock from one track to the another track. So, when we say there are two types of rails, one is defined as a lead rail, another is defined as a curved rail. So, these straight rails which are being provided here, they are the lead rails, whereas this one it is a curved rail. And these are also provided in the yards and sidings, because in the yards and sidings you will find that there are lot many tracks which are merging and diverging out of the main lines, and these helps in the reception of the trains as well as in making a new train in terms of the combination of bogies which will be dispatched from a station. Now, there are certain problems with these type of assemblies. One thing is, because we are talking about the n number of fastenings, we have this type of an opening being provided here. As I said, in this area there are points being set. So, these can work as the weakest points on the track. Another thing is the safety. Now, safety is always a consideration on the track, and here because of these weak points as well as the movement of the rails which will be taking place in this points and crossings area. So, here these are points and switches are being provided. So, there is a possibility that something wrong happens and it finally culminates into a hazardous situation. So, that is another issue with this type of an arrangement. And the third thing is that on the main track, the train may be moving at a maximum permissible speed, but when it has to take a turn based on this curvature, the speeds are going to be lesser. And if you remember, we did talk about the permissible speeds and the safe speeds in terms of the curves, in terms of the transition curves. And there we have found that the speed on the main track is higher, and as compared to that on the curve or on the transition curve, this is going to be lesser. So, it retards the movement of the train because there is a reduction in the speed. Now, let us look at the components of a turnout. Now, in this diagram, you can see that there is a straight track going from left to right, and then there is a track which is coming out of it and going towards the left hand side. So, there are different features being shown here. So, if we look at this rail being provided here as well as here, this rail is known as a outer straight lead rail, whereas the other one, that is number 2, this is a inner straight lead rail. So, it is going straight here. So, it is going in this direction as well as here in this direction. In the same form, when it is taking a turn towards the left hand side, then this one, number 3, is defined as a outer curved rail, and this number 4 is defined as a inner curved lead rail. So, we have 4 lead rails, but 2 are straight and 2 are curved in nature. Then at this point here, you can see that there is one rail being provided in black. So, this rail as well as the one which is provided here, they are the check rails. Towards the end of the previous lecture, we did talk about the check rails and why these check rails are provided. Then if you see here, there is a V notch which has got created. It is a combination of the outer rail and the inner straight rail. So, at this location, there is again this black color rail being shown. So, this is another type of a component which will be there. This is a wing rail being provided, and here there is an angle between the 2 rails. So, this angle is defined as angle of crossing. If you come towards the other side, here again there is a black portion being shown on the 2 rails, that is the outer lead rail and this is a inner curved lead rail. So, this is defined as the 7 number is a stock rail, and then with respect to this stock rail, here you can see there is another rail being shown inside. So, this one is known as tongue rail. Now, these 2 tongue rails, that is this one and this, these are both tongue rails, and here this is also a stock rail. These 2 tongue rails, they have been connected by these bars, they are known as stretcher bars. So, this is another component being provided here. So, these are more or less all the components which are there on a turnout. We have looked on those components in this particular diagram. Now, we will be talking about all of these one by one. Now, switches. Now, switches is a location where we have a pair of stock rails, a pair of tongue rails, a pair of heel blocks, the slide chairs, stretcher bars and gauge tie bars. So, here this is a section which is being defined as a switch. Now, in this switch we have these tongue rails. So, one pair of tongue rails is there, one pair of a stock rail is being provided, stretcher bars are provided. Then the heel blocks are also provided, which will be available at this location between the stock rail and the tongue rail. So, these are various components which will be there in the form of a total switch. The another important thing is the crossing. Now, nose, which consists of a point rail and a spice rail and 2 wing rails and 2 check rails, that is a crossing. So, here if again we see, so this is a crossing area. So, a V notch has got created here. So, here 2 types of rails are joining. So, one rail is known as a splice rail, another rail is known as a point rail. We will be talking why they are known as splice or the point rail. And This is a wing rail and at the other side is a jack rail being provided. So, this constitutes the overall crossing at this point. Then lead rails, we did talk about this. There are 4 sets, 2 are straight lead rails and 2 are curved lead rails. So, straight rail 1 and 2, curved 1, this is 3 and 4. Now, tongue rail. Now, this is a tapered movable rail which is made of high carbon or manganese steel to withstand wear. Its movement with respect to the stock rail defines the direction of movement of the rolling stock. So, here at this point between this particular location a tongue rail and a stock rail is being provided. We will go back and see that. Now, here you can see this tongue rail is moving away from the stock rail, but when it moves away from the stock rail at this location, the opposite location it will be touching the stock rail. That means any train which is coming from the right hand side, the wheels will jump over the tongue rail here at this location, whereas they will remain on the stock rail on the other side, and finally the train will move in this direction. But if suppose the train has to move straight, then this tongue rail will be touching the stock rail, and because it touches the stock rail, so the gap will come here, and because of that whatever the wheel flange will be coming moving on this outer rail will keep moving here, and at this location there will be a jump and it will move on the tongue rail and then finally it will be going straight. So, this is the way this tongue rail is going to control the movement with respect to the stock rail as well as movement in a particular direction. Now, this stock rail, this is the running rail against which the tongue rail operates. We have seen that how they work together. So, here you can see in a more clearer manner that the straight section is there and then the movement is going in this direction towards the left hand side. Here this is the stock rail, whereas this one is a tongue rail. So, what happens is that in this particular case this tongue rail is touching the stock rail here. That means, if any train comes from this side or is coming from the opposite direction, it will just switch over between the tongue rail and the stock rail at this point. But here there is a big gap, and because of that gap this wheel will continue moving on the outer lead rail. And in that sense, now if we have a crossing panel here, in between the crossing panel and the switch panel being provided, we have another section where there are closer rails. So, these are defined as the closer rail sections. Now, the another thing which we were discussing that there are slide chairs, stretcher bars and gauge type plates. So, these are the sliding system being provided. Here you can see this one is the sliding system and the stretcher bar is also there. So, these are operated from the side, mechanical system will be there. So, mechanical or electrical system if it is available, any of those, then this will move, this tongue rail will move leftwards or rightwards, and accordingly it will decide in which particular direction the rolling stock has to move. Now, distance block, this is a block which is used to fix the jack rail or the wing rail from the lead rail at a specified distance for a smooth movement of the train. So, they are going to be provided here or they are going to be provided in these locations, so that these jack rails or wing rails they remain at a specified distance away from the lead rails. Point rail. Now, point rail, this is a rail which ends at actual nose of a crossing and it has a blunt end. So, here you can see this is a crossing being shown. In this crossing a V is getting generated here by use of the two rails. Now, this first rail, this is going up to the end and this is the shape of the end of this rail, whereas the another one is just touching and closing on the another rail. So, here we have a point rail and a splice rail. Now, this point rail, this is moving up to the crossing. So, based on that, if we have provided this with a sharp edge in this form, so there will be a point which get created. Whereas in another case, what may happen that we just cut it here and we provide a shape in this form, and that means there is certain thickness which is being provided. The reason being that because of this very less thickness, if the load comes on this, it can break down. So, that is the reason we just blunt it here, and this blunting is actually 6 mm thick. So, with respect to this rail, the another rail which is going to be set here is the splice rail. So, splice rail is a cut or the splice rail which butts against the points rail. Now, because this type of a system is being provided, we are cutting it down. Now, the nose which is coming otherwise up to this point. So, this becomes an actual nose of the crossing, but when it is being cut, then this becomes a theoretical nose of crossing, but when it is being cut, then it becomes the actual nose of crossing. So, there is a slight distance between the actual nose of crossing and the theoretical nose of crossing. Now, wing rails, these are the flared rails. So, you can see that there is a rail being provided here and it is being given a flare on this side. That means the gap at this location and the gap at this location, they are different, it is higher at the end. So, they connects the lead rails at the crossing facilities and facilitate the entry and exit of the flange wheels into the gap. So, whatever the gap is there, in that the trains are going to move. Similarly, the chack rails, they are provided on the other side, again a flared section is being given. So, these are provided on the opposite side of to the crossing and they are running parallel to the lead rail. So, this one is the lead rail, here also we have a lead rail, and what they do, they are guiding the wheel flanges, they are preventing wear and rocking of the wheels and they are preventing the derailment at the level crossing. So, these are few of the points which we have discussed before too. Now, some other components are the flat bearing plates. These are provided under the sleepers as the turnouts do not have a cant. Then there are spherical washers. These are a special type of washers which can be used at such locations where there is a possibility of the movements, elongations, etc. and these washers very well fit in those. So, these are the washers which are used to connect two surfaces that are not parallel to one another. These can adjust to uneven bearings of the head or nut of a bolt and in a distance block behind the heel on the left side of the track. So, these are the washers which can fit in the some uncommon form of design features, whereas you have a bolt, but then it is straight, then it is fine, you can use a simple one, but when it is having say uneven systems or bearings, then these type of washers needs to be used. Then slide chairs, these are provided under the tongue rails and with the help of this only they moves laterally. So, they will be moving in this direction or is in this direction depending on which particular connectivity is to be provided. These are different for ordinary switches and overriding switches. There are types of switches which are available and here what we are talking is that. So, there are ordinary switches and overriding switches, for that the design is different. Now, grade of chair, these are special chairs which are provided behind the heel of the switch. So, the heel of the switch is at the back side from where it is moving. So, the location at this point there is a heel and this is the toe of the switch, and it gives suitable ramp to the tongue rail which is raised by 6 mm at the heel. So, at the heel if we talk, so if we have two rails, say provided in this form, then the another one so this level difference and this level difference, that is the 6 mm level difference which will be there. So, this is the stock rail and this is the tongue rail. Stretcher bars, these are provided to maintain the two tongue rails at a specified distance. So, we have the bars being provided here. So, with the help of the bars they will remain at a specified distance, otherwise there may be a movement, because if it is being hit or there are vibrations and it moves a little this way or the other direction, then it may cause a derailment also. Then gauge tie plates, these are provided over the sleepers and directly under the toe of the switches and under the nose of the crossing to ensure proper gauge at these locations. So, these are the additional features which are provided so that the gauge can be maintained at the locations which are the point of weaknesses, and there are a lot of changeover in terms of the directions and the movement and the lateral movement of the wheels and bogies, and because of that there is always a possibility of something bad happening here. So, that is where this needs to be maintained. Then we talk about the terminologies. The points is a pair of tongue rails and stock rails. The train diverting from the main track will negotiate the points first. So, when you are coming from a side and you have to take a turn, you are not going straight. So, these points are the first thing which the train will encounter. So, here these are the points which are provided, these are the tongue rails and the stock rails. So, this is a stock rail, this is tongue rail, and this is the head or the heel of the switch where we are going to have the blocks, and with respect to that now these are going to move. Now, crossing we talked about, this is a device at the junction of the two rails which allows the movement of the wheel flanges from one track to another. Nose, this is a point at which the two rails, point rail and spice rail meets, and it is known as a theoretical nose of crossing if the two rails meet at a point. I showed you that if this is how the two rails meet, but then one rail is going in this direction and another rail is being provided in this form. So, there is a theoretical nose, but if the toe of the nose is blunt by 6 mm here, so if this is being removed, then we are left with the system. So, there is a point rail and there is a splice rail, and accordingly we have a theoretical nose of crossing and actual nose of crossing. Now, throat is there. Now, what is this throat? There is a gap between the two wing rails. So, this gap is being provided here, and that is what is a throat. So, there is a minimum distance between the right hand and the left hand wing rails converging and diverging at the nose. So, you have the left hand and the right hand wing rail, they are converging here and then again they are diverging. So, at this point where they converge and diverge, whatever the gap is there is a throat. Crossing angle, this is the angle between the point rail and the splice rail, that means this angle which we are talking here is a crossing angle. Flare, the gradual tapering of the flangeway by bending the ends of the check rails or the wing rails at the heel of the crossing away from the gauge rail. So, this is a flare we are discussing, and all of these they are defined that how much the value needs to be provided, it cannot be more than that. Curve lead, so curve lead is, this is a distance from the tangent point to the theoretical nose of crossing measured along the length of the main track. So, the tangent point is starting somewhere here, from where the finally slowly and slowly it is taking a turn, and then it is going to the theoretical nose of crossing. So, the theoretical nose of crossing is at this point. So, this is the theoretical nose of crossing. So, this particular distance is a curve lead we are talking. Then switch lead, this is a distance from the tangent point to the heel of the switch measured along the length of the main track. So, again this is a tangent point, and from there we are coming to the heel. So, the heel of the switch is somewhere here. So, this distance if we talk, that is the switch lead. So, this is switch lead and this is curve lead, and the lead of the crossing, that means in between here. So, that is the lead of the crossing. So, this is L, which is nothing but CL minus SL. And all of these things, when we will be designing the turnout, we will again be talking about these distances. So, that is why you need to understand that what these distances are and how these are marked and calculated. Now, facing points, those where train passes over the switches first and then passes over the crossing. So, these are the switch panel on this side and the crossing panel is provided here. So, when the train comes on this side and it is passing on the points first or the switches first and then going over the crossing. So, this is a facing point. Trailing points, those on the opposite side of the facing points where the train passes over the crossing first and then pass over the switches. So, the one which are being provided on the other side, but that the train is coming in this direction. So, it will be coming from the crossing to the points and switches provided on this side. Then right hand and the left hand switch, it is seen on right and left from the facing direction. Now, the facing direction is what? So, facing direction is that you are looking from this side towards the crossing. So, when you are looking from this side and towards the crossing, then the left side switch or the right side switch, that is how they are defined. Similarly, the right hand or the left hand turnout. So, while crossing in the facing direction, that means this particular direction, when you are looking towards the crossing, if the train diverges to right or left of the main track, then the turnout is known as the right hand or a left hand turnout. So, in this case, if you see, this is a crossing is provided here, you are looking towards the crossing and this turnout is going towards the left hand side. So, it is a left hand turnout. Facing direction is standing at the switch and looking towards the crossing, that is how it is defined, and trailing direction is just opposite of it, that means you are standing on the crossing and you are looking towards the switch, then that will be the trailing direction. So, the various terminologies we have seen. Just look at here in this diagram. So, this is a facing direction, that means you are looking towards the crossing. So, crossing is here. Okay. So, in this case it is going towards the left hand side. So, that is where this is a left hand turnout. And similarly, the rest of the things we have already discussed about it, the theoretical nose, the actual nose, the stock rail, point rails, the combinations of the stock rails, tongue rails, which makes its points and crossings. So, these are again being shown here. So, it is just to refresh that whatever we have discussed, you can look at this diagram and get them clear. Now, switch angle, this is another thing. This is the angle between the gauge face of the stock rail and the tongue rail at the theoretical toe of the switch in its closed position. So, here this is an open condition and there it is a closed condition. So, at this point there is a block being provided. So, you can say that this is a straight rail, there is a block provided here and then there is a tongue rail and this tongue rail is going to meet the straight one here. So, this is the tongue rail and this one is the stock rail. So, in this closed condition there is an angle being formed here and this angle is defined as a switch angle, or we can say this is a beta. So, it is going to be dependent on this length of the tongue rail and the gap being provided here in terms of a heel divergence or a block. So, this switch angle as I have shown there is beta, it is a function of the heel divergence and the length of the tongue rail. It also depends upon whether the thickness of the tongue rail is considered or not. Say in this case the tongue rail, if we are assuming that the tongue rail here it goes and meets in this form and it becomes a point here. So, there is no thickness, but there is another case where it just stops here So, this is not there. So, it is a 6 mm again blunt edge. So, if we are considering in that form, then it will be different. So, it says if the thickness of the tongue rail is not considered, then this angle is defined as the sine inverse of heel divergence divided by the length of the tongue rail. Okay, so, the heel divergence which is coming at this point. So, there is a block as I said here, and then there is a rail. So, heel divergence is this distance and this is the length of the tongue rail. And if the thickness is considered, then it is thickness divided by difference in the theoretical and actual length of the tongue rail. Another one is the throw of the switch. The throw of the switch is the distance through which the tongue rail moves laterally at the toe of the switch to allow the movement of the train. So, if we go back here, now this tongue rail has moved away from the stock rail. So, this is the distance by which it has moved. This particular distance is known as the throw of the switch. That means, if here the throw of the switch is available, the train is going to move towards the left side turnout, but if suppose the throw of the switch is not here and the throw of the switch comes on this side, then the train is going to move in the straight direction. The limiting value of the throw of the switch on a broad gauge track is 95 to 115 mm. Now, let us talk about the heel divergence, because this is being provided at the heel where the stock rail and the tongue rail they are being connected. So, this is a distance between the gauge face of the stock rail and the tongue rail at the heel of the switch. So, somewhere at the back it is provided. Heel clearance is another name for the heel divergence. Now, this heel divergence, this is a flangeway clearance plus width of the tongue rail head at the heel of the switch. Okay, so, what is this? Let us look at this particular diagram first. So, there is a stock rail provided here. So, this one is the stock rail and this is a tongue rail. This is a heel situation. At heel, this is how they are going to look like. And there is a block being provided here. So, this is a block. Okay, so, heel block is there. Now, this heel block will keep these two rails at a specified distance, because they have now been connected by the nut and bolt systems and the fish plates. So, you have a fish plate here and the nut and bolt system being inserted in that. So, that means now this location has been fixed. Now, when you are talking about this heel divergence, so in the case of this heel divergence, it says that it is a flangeway clearance. Now, this is a flange. So, this flange can move in between. So, there is a distance by which it can move. So, we have a flangeway clearance available here. Now, this flangeway clearance, if we add to that the head of the rail section, then that becomes the heel clearance or the heel divergence. So, you can see here this is a heel clearance or heel divergence. So, there are two ways in which it can be calculated. We have a flangeway clearance being used here and the width of the rail head on the outer side, or it can be in the another form the inner value and this one. So, either of those can be considered. It varies between 13.7 centimeters and 13.3 centimeters for broad gauge, and this includes wear at the side of the rail head as 3 mm for 1 in 12 crossing and 6 mm for 1 in 8.5 crossing. We will be talking about what is this crossing 1 in 12, 1 in 8.5. Just at the moment understand it that there are different type of crossings which are defined, they are defined by the angle, and this angle is correlated with this way of writing 1 in 12 crossing or 1 in 8.5 crossing. So, when we are talking about this 13.7 and 13.3, we are also considering this value here. Now, flangeway distance or clearance, this was the distance between the adjoining faces of the running rail or the check rail and the wing rail at the node of the crossing. It allows the free passage to the wheel flanges. In the case of broad gauge track, minimum flangeway clearance of 44 mm can be used and at maximum it can be 48 mm. We discussed about this previously also when we talked about the jack rails. There we said the distance between the jack rails and the main lead rails shall be around 44 mm. Then another terminology is the flangeway depth. Now, this flangeway depth is the vertical distance between the top of the running rail and the heel block which is provided. So, there is a heel block which is provided. So, this is the top of the heel block, this is the top of the running rails. So, therefore, this gap is nothing but it is a flangeway depth. So, finally, this let us look at this points and crossing arrangements. So, points and crossing arrangements means we are talking one crossing on this side which is comprising of jack rails and wing rails, the nose, the theoretical nose of crossing, actual nose of crossing, point rails and the splice rails. Whereas, when we come towards the point side, here the switch is being created, there is a heel on this side, there is a toe on this side, there is a combination of the stock rail and the tongue rails, stretcher bars are also being provided, and all of these arrangement is finally being defined as the points on this sides and the crossings on the other sides. So, with this we close our discussion now. We discussed about the turnouts, we talked about the various components, we also talked about the important terminologies which are being used on the turnouts, and then we discussed about the points and crossings, and specifically certain discussion was there with respect to the tongue rail and their provisions and the arrangements of the points and crossings. We will continue with the discussion in the next lecture. Till then, thank you and bye.